So students, once again welcome back. Now these questions, as you know, are meant for your JEE Advanced crash course, fine. And one more important aspect is that in this particular segment I am trying to pick up some questions from your electrostat, electrodynamics, your simple circuit, like that, fine, combination of capacitors and all these things. Now let us take a look of this question number 1, that is, in the circuit shown in figure, C is equal to 6 microfarad, the charge stored in capacitor of capacity C is how much? Fine. So over here you have one circuit in which you are shown the combination of these capacitors, one is C, another is 2C, and it is connected with the 10 volt battery, and this is what? This is grounding. So you have to find the charge stored in capacitor of 6 C capacity, while C is equal to 6 microfarad, fine. So it is like that 6 microfarad, it is like that 12 microfarad, okay. So let us try to find the solution of this particular question. I am sure by watching the diagram or this combination you can conclude one solid fact very much, that is, both the capacitors are in series, fine. Both the capacitors are in series. So what is the meaning of this, that both the capacitors are in series? It means the charge on each capacitor is same, fine. The charge on each capacitor is same. It is similar to the combination of resistors, where in series current is same, in parallel potential is same, okay. So now when the charge is same, so how can we find C net? That is, these are connected in series combination, na. So you know the series combination capacitors equivalent to the parallel combination of the capacitors, sorry, resistors. So it is going to be, rather than writing 1 upon C net is equal to 1 upon C1 plus 1 upon C2, simply I am finding the value over C net is equal to C into 2C, 1 upon R net is equal to R1 R2 upon R1 plus R2 upon C plus 2C, clear. So it is going to be how? 2C square upon 3C, so it is C cancel. So 2 by 3C is the, you can say, correct answer. Now obviously I need the number, so value is given over here. So C net is equal to how much? That is 2 by 3 into 6, into 6, it will give me 4 microfarad, fine. Actually this 4 microfarad is the capacitance, the charge stored in capacitor of capacity C. Ultimately, after finding this value of net capacitance, fine, I can find the charge Q over here. So what will be the formula for that? Okay. So take a look over here, that is, sorry, it is 2 by 3C, fine. Now from here what I can do, I can say that potential difference, that is potential loss, V is equal to how much? So over here how much it is given? 10 volt, fine, 10 volt. So potential difference is 10 volt and Q is equal to CV, fine. So it is going to be 10 into 4 microfarad, it will be 40 microcoulomb, it is the charge, fine, 10 volt and this microfarad, it will give me this. So, from here C is your correct option. Okay. Then comes question number 2, which is in the same category, that is only one option is correct. Fine. So, it is the gap between the plates of a parallel plate capacitor is filled with glass of resistivity rho. Glass, a type of you can say quartz wool or like that, fine, or if you are comfortable with that, you can consider kaach, glass, fine. The capacitance of the capacitor without glass is equal to C. Obviously, after placing this dielectric, it should increase capacitance. The leakage current of the capacitor when a voltage V is applied to it. Actually, why the leakage current will take place? So, obviously, you know it is a type of dielectric material, charge accumulation will take place, polarization of the charges will take place, accordingly some electric field will be developed, so many things will take place. We are just interested to find out the you can say solution for this particular question. So, gap between the plates of a parallel plate capacitor is filled with glass. It is like this. I think I should use a red color chalk to show you. Let us say this is one plate, okay, and this is another plate, fine. This is glass filled over here everywhere, and the resistivity is rho, fine. Now, capacitance of this capacitor without glass is C. So, after filling this, you have to find the leakage current. R is equal to resistance, we have a formula rho L by A. So, rather than writing this, I am writing in the form rho D by A. I am sure few of you will be confused. What is the meaning of D? D is spacing between the plates. So, rather than writing this R is equal to rho L by A, I use this formula because these values are given to me, fine. So, from here I can say, I hope now the terms are clear, I leakage, oh no, I think I should write it down complete. It means leakage current I leakage, okay, is equal to V is equal to IR. So, V by R. Now, what is the value of R? So, I will put, oh, such a simple question. So, it is going to be A upon rho into D, clear. Now, problem is that we have to talk in terms of the capacitance. It is not like that I have to talk in terms of the leakage current. So, ultimately I have to change this value. So, let me allow to do one thing. I leakage is V A by rho into D, I mentioned over here. Now, I will use this space and this term is available to you. I have one basic formula, C is equal to epsilon naught A by D when no dielectric in between the plates. Otherwise, I have to write down K epsilon naught A by D, but no dielectric, so air is there, so K is equal to 1. That is why I mentioned C is equal to epsilon naught A by D. Now, from here what I can say that A by D is equal to C upon epsilon naught. Fine. Now, A upon D is equal to C upon epsilon naught. Do one thing, replace this value of A by D in terms of this over here, fine. So, what I will do, please use this value. So IL is equal to V upon rho into C upon epsilon naught. I hope you will find it simple enough to you can say consider. So which one is the correct option? So it is, I am trying to squeeze myself at this point. Just take a look of the B option and take a look of this particular expression. So B is the correct option. Over there it is CV, over here it is VC. No problem, you have to just arrange the terms. Fine. And yes, sometimes because as per the given options you have to do the makeup of the you can say solution or answer of the problem, and accordingly you have to move. Fine. Now let us move for question number 3. A solid conducting sphere of radius 10 centimeter is enclosed by a thin metallic shell of radius 20 centimeter. So I think first I should draw a simple diagram. What is the diagram? It is hollow spherical thin metallic shell of radius, let us say 2r. Why I am considering 2r? Because then I will consider another as r, so it is 20, so that one is going to be 10. And within it basically this is solid sphere, conducting solid sphere. Fine. And its radius is r. Okay. A charge q is equal to 20 microcoulomb is given to the inner sphere. Over here charge is placed. Please, over here charge is placed. Fine. Find the heat generated in the process, I mean in the process of putting the charge. The inner sphere is connected to the shell by a conducting wire. So you have to consider few simple facts. Thing is that it is specifically mentioned that this solid sphere is a conducting sphere. So when you place the charge, so what will happen? Whole of the charge will redistribute itself onto the outer surface of this solid sphere. So I think I should write down this statement. Just take a look of the question. I am out of your frame. Fine. This way. Think on it. Now I am coming. Please allow me to hide some portion. The total charge transferred, no, not transferred, provided, given, okay, given to solid conducting, please be careful, conducting sphere. The total charge given to solid conducting sphere will come up. This long statement I am writing so that you can understand what exactly the point is. Fine. So sphere will come up on the outer surface. Fine. It is a type of redistribution of the charge. Fine. Now from here what exactly we can conclude, that once the entire charge is distributed on the solid sphere and you are connecting the solid sphere by a conducting wire to the shell. Fine. So the idea of, you can say, induction is not going to applicable over here as such. Fine. So outer surface, upon the outer surface, therefore heat generated is what? Is difference in energy. I think I should mention it first like this, delta U, and then it is U initial difference U final. This is going to be the what? This is going to be the energy stored over here. So H, heat generated, is equal to 1 by 2 Q square upon C1. C1. Why we are using this C1? Reason is simple. It is a consider a water bottle. Okay, best example, hollow water bottle. Hollow means water is not there, and let us say its capacity is 1 liter. Imagine. So, you know that because it is mentioned on the water bottle, so you can say, okay, I am going to put 1 liter water on this inside this bottle. Fine. Now, this is isolated conducting sphere. So, there must be some limit of the charge that you can provide this, obviously. So, why not talk in terms of the capacitance? Fine. So, it is H is equal to 1 by 2 Q square upon twice C1. C1 is associated with what? That solid sphere. C1 minus 1 by 2 Q square upon C2. C2 means outer cell. Fine. So, 1 by 2 this Q square that you can take out common, but consider the scenario for the C1 and C2, and that I want to mention over here above this. That explanation which I just removed was for the reason that yes, you can understand properly the scenario. Now, consider from here what you can say, that C1 is equal to 4 pi epsilon naught R1, and in my problem R1 is how much? Capital R, and C2 is equal to 4 pi epsilon naught R2. Value of R1, R2 I assumed like R and 2R, no problem, we can put the values over here, and after solving, let me solve it for you. H is equal to, fine, after putting the values of C1, C2 you can write it, Q square upon 8 pi epsilon naught R2 minus R1 upon R2 R1. Clear? Now, R1, R2 values I mentioned over here. So, let me allow to put the values. What exactly the charge is? Charge is 20 into 10 to the power minus 6 square. Fine. Then 8 pi. So, you can do one thing, 1 upon 4 pi epsilon naught is 9 into 10 to the power 9. Okay, and that too divided by 1 by 2. So, I think I can directly put it like this way, 9 into 10 to the power 9 within bracket 2R minus R, that is R upon 2R square, 2R square. So, RR get cancelled, and the value of R is how much? It is going to be 10 centimeter. Put the values. So, H is equal to 9 joule is the correct answer. Well, I will classify this question in the category of moderate to difficult. Moderate because initially whatever you have to visualize, you have to transform that visualization in terms of that particular topic which is mentioned in your course curricula as capacitance of an isolated sphere. So, that one aspect is there. Now, from that aspect if you visualize this part, then after that calculation, because if you directly start putting the values over here, it is going to be more complicated. Fine, that is why I use this value over here. So, let us move away. So, these three questions were from the category of only one option correct. Fine. From here now, I am going to consider question number 4, and question number 4 instruction set is more than one option correct. Actually, it is not like that always more than one option correct, but sometimes it possible. Now, these are really dangerous questions. Problem is, again I would like to mention, and in my each video I am saying this particular line just because of the reason I want that you people should be careful enough to attempt these questions. Say for example, A and D is the correct option. Every time I am using this example. Let us say I calculated A, correct, fine, I will get some marks. Okay. After that, let us say I marked C. while C is incorrect option. So, you know what will happen? Whatever the credit given to you by for this A is going to be nullified and you will be negatively penalized. So, rather than getting some positive marks, you will get negative marks. So, please be very careful, extra careful, use this set of questions like, if I know the correct options, only then I will mark. Let us say out of 3 I calculated, I found that only 2 are correct. Let us mention them, move away, so that you will get some positive marks. So, please do not commit this mistake, at least in JEE Advanced stage exam, where every marks count a lot, not only every mark, where point marks also calculated like this. So, let us consider the problem. A point charge q is placed at origin. Okay, no problem. Point charge is placed at origin, fine. When the lines are with you, I hope it is easier for you to visualize. Let EA, EB and EC be the electric fields at 3 points. Point A is 1, 2, 3. So, we are talking in terms of 3 dimensions, that is why I created x, y, z. So, it is like that. If it is y axis, it is x axis, it is z axis. In a room where you are watching this video, you can imagine like that, or in front of me x, y and z. So, 1, okay, 2, 3. So, somewhere in air the point is going to be over here, fine. And after this, you know what will happen? After this, B point location and C point location is given. Now, due to charge q, okay, charge is placed over there. So, in 3 dimensions electric field, come on, it is like that, because charge presence can be felt in every direction. So, that is why we are talking in terms of this situation. So, it is going to be, then we have to find which one is the correct option, fine. Let us take a look over here. That is EA. It is not required very much that I should write it down, but if few new students are watching this video or like that, so I have to explain it. EA along, okay, EA along in which direction? OA, vector OA. Similarly, you can write down EB along OB. Similarly, you can write down EC along OC. Clear? So, let me allow to write down one more line. EB along OB. Actually, you know what I am doing? I will use 2 directions, x, y. I will show, and you know that after getting the information about these 2 directions, the third is going to be clear to you. Okay. So, EB along OB, EB along OB. Now, OA is what? Oh, OA is I cap, very good, plus 2j cap, okay, plus 3k cap. What I did? Just compare these numbers, and OB is equal to, take a look, I cap, good, plus j cap minus k cap, fine. So, now these 2 vectors are with me. Do one thing, OA, okay, dot OB, okay, is equal to 0, very big Y. Many of you will say OA dot OB directly is equal to 0. How exactly possible? Come on. What is the direction of x and y with each other? 90 degree. Take a look. And cos 90 is 1. Come on, cos 90 is 0. Sin 90 is 1. So, with the understanding of this, I can simply say OA dot OB is equal to 0. It is like this way, perpendicular. So, that is why I am saying it is going to be 0. Now, if it is 0, then please give me one opportunity to write it like this way. That is EA, actually this I should not write it down, but anyway, EA EB. It means proven na, that EA and EB are perpendicular to each other, and we proved it other way round. So from here I can say mod of E is directly proportional to 1 upon R square. So let's try to find out the solutions. Okay, so EA is perpendicular to EB. Please look at me, I mean not at me, but take a look of this option A. Fine. So that is one correct option. Another is EB is equal to 4AC. No, I not found any type of this thing. Then EB is 8 times. I also not found like this. EA is parallel to EC. Obviously, EA is parallel to EC. How? Take a look of this. Fine. So over here more game is associated with visualization. I tried my best to use this diagram, also using these you can say chalk holders and giving you the idea of your room, directions x, y, z, so you can visualize it. Fine. And these type of questions where some directions and some initial you can say explanation is required, they are not difficult as such, but yes, visualization is required. So I will put this question in the category of moderate, not difficult one. Fine. Let's move for question number 5. Actually question 5 and 6 is based upon comprehension type. Comprehension type, you know, you have some information given, and after that you are given a question. Fine. So this is the information, simple information. A charge Q, negative charge, is placed at 1m, 2m, 3m, 1m, 2m, 3m points, 1, 2, 3. There is a point P, 2m minus 3m, 4m, you can visualize easily. Okay, this is the information. Fine. After that, this is your question based upon that information, that is question number 5. And after that there is one question, that is question number 6. So both these questions are based upon this small information. Fine. I think the situation is so simple that I need not to show you this information again and again. You just have to close your eyes and imagine 3 points in space and place a charge at this particular situation in air. Fine. Let's take a look of question number 5. A unit vector in the direction of electric field at P due to charge Q will be. Okay, we have to find the unit vector. Fine. Now, question is based upon electrostatic charge, but idea is associated with what? Idea is associated with the concept of you can say vectors, you can say properties. Let's try to find out the solution. Actually these are options, so right now we don't need to look on these options. I am writing one situation, unit vector R. Unit vector R, why I am writing? Actually I have one vector, position vector at which charge is placed. I have another position vector where this point P is situated, that was given in the information. So I am trying to find out this position vector, unit vector R minus R2, or I think I should mention it like difference. Okay, vector R1 minus this and vector R1 minus R2 vector mod. Simple. So that formula we can write it down over here. So from here R1 minus R2 is equal to, that is going to be how much? The information is on the back slide like this. So 2 minus 1, just think, minus 3 minus 2, 4 minus 3. So we are doing that thing. So over here if I will solve it, I will get minus I cap. Fine, with the help of those numbers, minus I cap plus 5 j cap. Okay, nothing is complicated I am doing, I am simply arranging the terms, k cap. Now for this particular situation I can show what is the mod of this particular information, what is the mod? So minus I cap, okay, plus 5 j cap, okay, minus k cap, minus minus. Now this is B is going to be your correct option. Fine. Fundamental property of vectors has been used over here. After that, next question, but that question is also based upon the same set of information. Component of electric field along x axis at point P would be how much? I think I should write down the formula over here, that is going to be E is equal to 1 upon 4 pi epsilon naught Q upon R cube, yes, vector R1 minus R2. Clear? This is the basic result, and what is the value of this? 9 into 10 to the power 9. Fine. So, what I should do? I simply should say that after putting the values, after putting the values and solving, I will get 2 upon 9 root 3 as the correct option. There is no point for me to put the value, multiply 2 by 9, write down 18 and so on. Fine. One more thing that you should consider over here. Calculation obviously must be fast enough, that is at most important. But calculation fast, okay, but it should be correct also, accurate also. Fine. Then comes question number 7, that is, this one is matrix match type of question. Well, nowadays the trend is in these type of exams that these question not only check the capability of the student to solve a question correctly, but also lot of associated concept. In one question many concepts can be checked. Say for example, consider this particular situation. 5-point charges are kept at 5 corners of a regular pentagon. So, first I think I should draw a regular pentagon. Fine. So, what I should do? Like this, like this, like this, like this, like this. Fine. So, it is 1, 2, 3, 4, 5. Fine. This is regular pentagon. With the free hand I am drawing. So, I hope up to some extent you will consider it is okay. Now, so 1, 2, this is just a representative diagram, 3, 5, 1, 2, 3, 4, 5, fine. 5-point charges, it is not given positive, negative. One charge is now removed, okay, removed. Let us say for example, 5th charge has been removed. Match the following table for above 2 situations. So, initially 5 charges were placed, point charges, after that 1 charge removed. Now, what will be the situation? So, that we have to consider. Now, problem is as such any solution is not given for this particular problem. What exactly is given? You have to consider one statement, analyze the statement on the basis of this information. After that, go for finding the values which one is correct. Say for example, over here one statement is table 1, first statement, electric field at center of pentagon in case 1. What is the case 1? Case 1 is when all the charges are placed at their respective positions. Fine. So, the electric field is going to be how much? Now, what the answer that will come in your mind, that in this scenario, in case 1, net electric field at center is 0. Clear? I hope you can say yes, it is fine. Well, how it is? If someone of you are thinking like this, then my suggestion is, please show the direction of the field at the center. They will cancel out each other. Fine, because they all are positive charges, one will remain absent. No, it is not like that. The angle resultant of that particular electric field, it is a vector quantity. Next is electric potential at center of pentagon in case 1. So, it is first case. Next point is in case of this electric potential, fine. B, what will be the electric potential in this scenario? That is going to be, in case 1, potential V is, in case 1 potential V is, well, it is a scalar quantity, and the addition of this potential is going to follow what? What exactly it is going to be? Algebraic law, fine. So, it is V is non-zero with some value. But very beautiful aspect of this question is this one not correct. Non-zero, yes, non-zero, but what will be? So, ultimately safest point is you simply say for B, Q is the correct option. So, it is P, it is Q, fine. Then come on to this C scenario, electric field at center of pentagon in case 2. Now, in case 2, when one charge is removed, then situation is going to be different, fine. When it is for what, you know, it is for case C, when one charge removed, okay. So, now total charges are left 4, but all those 4 charges are at 5 corners. So, it is like this one, and one over here. This charge is missing, not there. So, these 4 charges will definitely give some resultant field, okay. So, when one charge removed, only 4 charges left, fine. So, E net has some value. So, therefore, what you can say that C Q is correct. It's definitely not going to be 0, it's definitely going to be some value. Consider electric potential at center of pentagon in case 2. Now, over here you can say, sir, there is no point of explanation, simply say V is non-zero because it is algebraic sum. So, when 4 charges left, obviously it has going to be some value, and that value is 1 upon 4 pi epsilon naught Q upon R1 plus R2 plus R3 and so on, fine. So, that way you can say over here P Q, it is also Q and it is also Q. So, this question was quite simple one, fine. Otherwise, P Q, let us say one more option R, P Q R, one more option S, then it is going to be really a complicated scenario. Anyway, I think we should stop over here, fine. Soon I will come back with some new questions. Till then, take care of yourself, have a nice time.